Hey, folks, today we're going to go over some of the skills that we have been learning lately in the last couple sessions. We're going to start off with taking a look at story problems. So when I read, I'm going to read it through one time and then I'm going to go back and visualize it and underline the data that's going to help me solve it. So here I go. 4 classes of third grade students went to the museum for a field trip. Oftentimes I like to stop at the end of a sentence and think. So I'm imagining 4 classes of third grade students going on a field trip at a museum. Each class had 27 students. Okay, so they have the same amount of kids in the class. They're all 27. How many third graders went to the museum in all? So let's go back and we're going to underline our data. 4 classes of third grade students went to the museum for a field trip. So I'm picturing 4 classes. Take note that they actually wrote this in word form. So sometimes they'll throw you off by writing a number in word form instead of writing it in like digit form. That's what you're going to start noticing. And they might even interchange it. In fact, they did in this one. Let's take a look at the next sentence. Each class had 27 students. Notice they wrote this one in digit form. So the authors of these story problems do a lot of stuff to kind of throw you off. I think even having third in here kind of is a little bit confused. It may be a little confusing. Some kids might think, oh, well, I need to have a 3 somewhere in my problem. But we know that the grade level, after reading this, how many third graders went to the museum, they could have said second grade students went to the museum. And in the question, how many second graders went to the museum in all? So it didn't really matter the grade level. What mattered was the amount of classes, 4, and the amount per class, 27. So if you haven't figured it out by now, 4 classes with the same number, 27, in each class, we know that that is 4 times 27. Or you could even write it 27 times 4. Either way is correct. So there's our single digit by double digit multiplication problem that we have been working on. So remember, there's 2 ways to do it. They're both very similar. I'm just going to start out by doing the area model, but I'm going to do something a little bit different. We're going to put our single digit on the short side of the rectangle. And then remember, we decompose 27 into expanded form, which is 20 and 7. So I'll write 27 here, and I'm going to draw my line. Instead of making base 10 blocks in a separate spot and dragging them, I'm going to actually show you. We can actually do the base 10 blocks in here. 10, 20, 1, 2, 3, 4, 5, 6, 7. There's 1. 10, 20, 1, 2, 3, 4, 5, 6, 7. There's 2. 10, 20, 1, 2, 3, 4, 5, 6, 7. That's 3. And remember, we're trying to get to 4 rows of 27. 10, 20, 1, 2, 3, 4, 5, 6, 7. So this is the area model kind of combined with the base 10, where we drew the base 10 blocks in the area model. And if we counted up all these 10s, this is a 20, this is a 20, this is a 20, this is a 20. It's the same as doing 20 times 4. So 4 times 2 is 8, with the 0 is 80. So let's check. Is this 80, 10, 20, 30, 40, 50, 60, 70, 80? So our answer in here is 80. And then 7 times 4, if I counted every single one of these, 7, 14, 21, 28. All right, that's 28. Or 7 times 4, if you just have it memorized, it's 28. So this is the exact same thing we have been doing, but I just kind of combined them because they are the same. So 80 plus 28 is 108. And if that didn't come that easy to you, let me just stack it here. We'll show you the traditional algorithm. 0 plus 8 is 8. 8 plus 2 is 10. 108. And it's 108 third graders. Sorry. All right. I can't write with this mouse. Okay. Let's try another one. Okay. Oops, I gotta move this here. Mrs. Russell was getting ready for a big party. She bought soda and bottled water in 6-packs. Okay, so I'm picturing that. I could definitely picture soda in 6-packs. I don't know if I've seen cases of water, but yeah, they probably sell bottled water in 6-packs also. Okay. As she was checking out, she counted 22 6-packs. How many drinks did she buy for the party? Okay, so they're combining the soda and the bottled water, and they both come in packs of 6. So I'm assuming there's 6-packs of soda, 6-packs of water. She's combining both between the soda and the bottled water. There were 22 6-packs. How many drinks did she buy? So now it's not how much soda or how much water, it's how many drinks total, which they're both types of drinks. So there's 22 6-packs, which means there's 22 times each one is worth 6, right? So it's another multiplication problem. So we'll set it up. Area model, single digit on the short side, double digit decomposed, 22, draw the line. Now, if I wanted to, just like the last one, I could go 10, 20, 21, 22, and we could draw this 6 times like this, and then count up your base 10 blocks. This is what? 1, 2, 3, 4. This is only 5. I'm going to need to squeeze 1 in the bottom here. 10, 20. Here's my last 22. And you can count all that up. That's one way. I personally, I like to take shortcuts. So my shortcut is not even bother with the base 10 blocks. I'm just going to do 6 times 20, which is the same as 6 times 2 times 10. So 6 times 2 first would be 12 times the 10. You just tack a 0 on the 12, and the answer becomes 12 with a 0 is 120. And then finally, this row multiplies by this column. 6 times 2 is 12. And we simply add up our areas. 120 plus 12. 2, 3, 1. So our answer is 132. And then what was our unit? It wasn't soda, it wasn't bottled water, it was them combined. So it was 132 drinks. Okay. So that's that for the story problems. Hopefully that will help you for today. We're going to start another, not start, but I guess continue another type of problem. The twist to this one is we have to decide if it's true or false. So keep in mind we're doing like a balance scale. Okay, we have to see, does this, since that says this is equal, this pan balance needs to balance. That means this has to be the same as this. So doubling 8, I already have my facts memorized. 8 times 2 is 16. And I know my square facts. 4 times 4 is also 16. So the question is it true or false? 16 is equal to 16. True or false? Well, that's true, my friends. Okay, let's move on. See how I'm solving both sides. Here's another one. 7 times 13. Okay, there's the equal sign. So that means that we should be able to balance. These should be balanced if this is true. Now, I'm not even going to solve. I could solve this, but I'm just going to kind of analyze what they did. Because I know when we decompose a single by double-digit number, we do the 7 times the 10, and we do the 7 times the 3. And let's see what they have over here. There's a 7 times the 10. So we've accounted for that. And then adding it to the 7 times the 3, we're accounting for that. So I don't even need to solve this to know that this is also a true statement. Okay, so that's true as well. They would balance. And let's try another one down here. 5 times 30, they're saying, is the exact same as 5 times 3 times 10. Well, let's think about what a 5 times 30 is. How do I solve a 5 times 30? I usually start with the 5 times the 3 first, is 15, and then you times it by 10 by just putting that 0. Isn't that kind of what they did? If we just go left to right here, we're doing the 5 times 3 is 15. And then you're going to times it by 10, 150. So once again, this is a true equation because it would balance. So all 3 of them ended up being true. Perhaps, there might be an example just to show you what one that might be false may look like. They might switch one of the symbols and kind of throw you off a little bit because teachers like to be sneaky like that. So in that case, if you did the 5 times the 30 and you solved, oh, well, this is 150, and then you did this one, 15 plus 10, this would be 25 on that side, then you know that that is actually a false statement here. So last page that we're going to review, it's just the order of operations. What order do we solve? And this is the thing that I want you to take home with you. You solve the parentheses first. So for this example, 6 times 8 plus 2, there's parentheses around the 8 plus 2. That makes a 10. And 6 times, oh boy, I'm almost done with the video, and one of my children left the refrigerator open, so I'm gonna have to go shut that. I apologize for the delay. So back to business. 8 plus 2 is 10, times 6 is 60, because 10 times 6 is 60. Now let's move down here. If you notice, some of you guys are really good detectives. You probably notice these are the exact same numbers, the parentheses in a different spot though. So let's see if it changes the problem if we do parts of the problem in a different order. Let's do 6 times 8 first. So 6 times 8, if you know your facts, 6 times 8 is 48. Hopefully you know your facts and you didn't have to draw that out. Plus 2 is 50. So depending on where the parentheses are, it may change the answer. Sometimes it does and sometimes it doesn't. I've seen it where it doesn't make a difference which order you do the problems. So let's see another one. There's going to be another set of problems down here. They're the exact same numbers, exact same symbols. We're just doing them in a different order with the parentheses. 4 minus 2 is 2. So 24 divided by 2, which means you're cutting it in half, is 12. And then this one, 24 divided by 4 is 6 times 4 is 24, right? So this would be a 6. And then minus the 2, it would make this a 4. Okay, so back to the advice up here. Solve the parentheses first because it will change the outcome of the entire problem. You're going to have problems where you have to solve there's parentheses in the equation and you have to make sure you solve the parentheses first in order to get to the correct answer. All right, that's our review for today. Come back as many times as you'd like for some repeated instruction.